Okay. As you know, maybe we have a YouTube channel where we put all the videos of tutorial videos for the usage of the ClimSA station. So all the options, all the way to manage and to use the ClimSA stations is explained in our YouTube channels, where we put some different very small videos, very short videos for every single task. And we also put this kind of usage and feedbacks of the ClimSA station, because usually we have a scientific presentation in this meeting, and we have also some open discussion that could be also very interesting in the future. So if you miss one of the UaF, you will find all the historical ones in our YouTube channels. So if you look at the ClimSA station on YouTube, you should find our channel. So basically, today we will focus more on climate projections. So you know how it works. We have we try to make a short presentation of about 25 minutes. We're about a presentation of a specific scientific product, or I mean a tool or whatever. Today it's going to be the climate projections by one of our colleagues, Alessandro Dossio. But before we will give you just a very brief update of the ClimSA stations. And then the second part of the meeting will be on the climate projections that we have already included into the ClimSA station in our ClimSA station locally. So you will have a brief presentation done by Vijay about how to manage it. And then we will finish by an open discussion that is about that could be related to the climate projections, but also another topic related to if you have a problem with the ClimSA station, if you want for the next UaF, if you want we speak about a specific point. So that will be a completely open discussion where we can Vijay, Jurjen, Dario, and of course Alessandro Dossio and myself will be there in case of you need it. Okay, so let's start with the 5 minutes info, about 5-10 minutes about the updates of the ClimSA stations. The ClimSA station. So basically, we have a new release that is available, the version 1.1.4. And we have also new data sets. Basically, it's, for example, the seasonal forecasts. We have also some data related to climate projections, but that point will be discussed after the presentation done by Alessandro. Maybe I can give the floor to Vijay, that will discuss quickly about these two first points. Vijay, if you're,
Yeah, hello. Hi, everyone. So hope you're doing good. So now I will just quickly update you about the ClimSA station developments. Some of you, I guess, in the regional levels, we installed the 1.1.2 in March, at the end of March, April. And then we also did quick updates, two different versions, 1.1.3 and 1.1.4, mostly to fix the bug fixing and then some other minor changes. So we moved from the building mechanism to the installer, but I'm not going in detail about all those things. So if you don't have the latest version, that is 1.1.4, still it's fine, because for some of you, you might already have 1.1.3, which is updated separately, and then the impact toolbox separately. So in this latest release 1.1.4, it is a single version where all the mechanism are done automatically. So if you have 1.1.3, it's still fine. You don't need to go for 1.1.4 because they are minor changes. So as long as you can utilize the system, it is fine. So this is about the release of 114. And then another changes in the data sets, or we have a couple of new data sets made available, especially for the seasonal forecast anomalies, and then the climate projection data set, mostly used in the Jupyter notebook, not directly from the portfolio. So from the continuation of this presentation, you can go through what you are interested in, and then on the Jupyter notebook we can make available some of uh, the visualization of climate projection data sets, and then um, provide you the Jupyter notebook where you can work, start visualizing the data sets, and then analyze some of the time series. So this is about these 2 points on update of the ClimSA station. And if you have any other doubts, we can discuss in the last part of the meeting, of the open discussion. So maybe now I give the floor to Urian for integration of station data to give you a quick update, which we have done. So Urian, if you can unmute. Also, Christoph, I noticed that I couldn't. Nobody can unmute.
No, it's normal. I mentioned that it's to avoid, because I to avoid any problem with the sound. Okay, yeah. So Jorian, for the integration of station datasets into the ClimSA station.
Yes. Okay. Hello, everybody. I am Jorian. I'm responsible for to implement the integration of weather station data into the climate station. And for that, I would like to shall share my screen. Okay.
Okay. Yeah.
See something?
Yeah. Perfect.
Okay. Let me move this. Okay. So maybe I can start with some slides. So there are 2 things. So there are actually for the integration, there will be a mechanism implemented to import ClimSoft data into the climate station, but also of course from other systems like Clyde or ClimSys or CliData. So for all these softwares that are used, there will be an import mechanism that will be available then within the Jupyter notebooks, where you can upload your, let's say, export from your system of the needed data. And from the Jupyter notebooks, you will have some functionality available where you can easily import your data into the climate station. For this, a document will be written and distributed to all of you to give you an indication on how you should export and what kind of data you should export from your software. Then there's the second part of the integration of meteo station data. That is the visualization of the station data within the analysis tool. And for that, I'm going to give you a short presentation of what has been done until now. And also blending station data into rainfall products, which will be available as a functionality within the Jupyter notebooks. So the idea, okay, I can maybe directly show you through the user interface. So you might all be familiar with the analysis tool. Here I have one map open, and now there's an extra button here that you see where you can show all the stations that you have in the system, and actually imported in the system. As you can see, I have some test data which I got from both ICPAC and from Namibia. Okay, I can maybe show you quickly. Okay, here you see a pop-up with which I have to change, which gives you all the information about the station when you go over. Then let me zoom out a bit and go to another region. Then once you have, let's say, once you show all the stations, then you can select them also by selecting an area. In this case, it is all of Ethiopia. There seem to be 20 stations in the test data. And you will see then also the available observation types, which you then can select to include, maybe also together with CHIRPS data, for example. So we can add also CHIRPS data like this. So then you have selected products over all of Ethiopia, together with the 20 selected stations. And for this, which still has to be implemented, you can generate then your time series. Okay, you have to give a date, of course, and that's it. So for now, that is the functionality that has been implemented, and soon also the time series for the profile with integrated with the weather station data will also be implemented. Yes, I think that's it, Christoph.
Yeah. Okay. Thank you very much. Yeah. So it's a very important and a very important new feature of the ClimSA station, because now you will be able to play also with your own station data. And again, of course, if you don't want to share that, I mean, including the station into the ClimSA station doesn't mean you're going to share with everyone. Huh? It's you're gonna, it's protected, and so don't be afraid to. We don't ask you to share all your station data, and you can manage your own data. It's just a way to insert them into the station. Thank you very much, Jurjen. So maybe you can stop sharing your screen if you can. And I think, yeah, according to the agenda, we can go now for the scientific presentation. So Alessandro, if you're okay.
I need to share my screen.
Yes.
Oh.
So the floor is yours about presentation of the.
Yeah. Okay. Thank you. First of all, for those who don't know me, I see a couple of names I recognize in the list of attendees. I'm happy to see them again, but most of you I don't know. So I don't know whether you know everything about climate models, climate projection, and how to use them or not. If you know anything or everything, this presentation will be rather boring. But if you don't know, or if you don't use climate models so much, so maybe there are some useful information from you. And first, some apologies because I just came back from holidays, so this is not exactly a tailor-made presentation for the workshop. It's just some, let's say, presentation I gave some time ago, then I sort of adapted for this meeting. But basically, basically this is a compendium of I have to tell you first that I've been working on climate projection for Africa for a while now, a few years, basically at the regional scale with the regional models. Yeah.
Alessandro, just if you can shift to full screen.
Oh, yes.
Presentation mode.
Yeah, sure. There. Oh, no.
Okay. Or we see the presentation for the presenter mode.
Yeah, I don't know how to.
Yeah, but so stay in without the presentation mode.
No, that's worse. Okay. Well, never mind. This one? No. Okay, never mind. So you will.
Well, you can shift to the previous mode.
Okay. No, that's okay. Okay, fine. So basically, this is a compendium of a few works that they did in the last few years. They are here. If you want to read them, I give you some details later on. So, okay, few words about models, because there is actually a lot of models out there. I will start with global models, global climate models that are those that have been usually in the IPCC reports. The latest class of climate models, global climate models, are called CMAP5 and CMAP6. CMAP5 are used in, let's say, ERA5, so their last IPCC report, the last but one, and CMAP6 are used in the last one, ERA6, the last report that we released a couple of years ago. There are differences between them. I don't want to enter into details. The things is there, so quite a lot, and for quite a lot of RCP scenario, basic concentration scenario. So 2.6 low emission scenario compatible with the 2-degree warming at the end of the century, and 8.5 is a very warm emission scenarios. So there are around 20 or 30. So this obviously wrong. Anyway, this should be 32. Anyway, around 30 simulation for any of this scenario and around 25 for CMAP6. And these are available in the sense that I use them. I tell you later how. Then there are regional models, and regional model are models, climate model that works on a region. In this case, they work on Africa, on this domain, in the framework or a project called CORDEX, which is the World Climate Research Program initiative to produce regional climate information for all the land region of the world. And Africa was the first target. So we have quite a lot of simulations over there. Regional models work that you have a regional model, and this model is driven by a global model at the boundaries over here. So you have a combination of regional and global models, and here you have the standard CORDEX models, let's say standard CORDEX simulations, which are around, again, depending on the scenario, between, let's say, 15 and 25. And there is a new set of simulation called CORDEX Core, which are higher. Oh, sorry. These CORDEX standard CORDEX runs a resolution around 50 kilometers, it's 0.44 degrees. Whereas there is a new set of CORDEX Core simulation runs at 25 kilometer resolutions. The problem is that since they are quite expensive, and to my experience, the information that you gain from 25 kilometer resolution compared to 50 is not so much. Anyway, there are only a few runs, only 9, actually basically only 3 regional models that downscale 3 global models. So, and only for 2 scenarios. So there are not so many. Anyway, now the question is, okay, and then these data are usually daily data, okay, for a number of years, usually from 1950 to 2100 under different projections, emission projections. And then you can calculate some indexes. For instance, these are indexes of precipitation. They are standard called ECTDDI indexes, so this expert team on climate indexes. And they're basically standard seasonal mean, but also indexes of extreme events, the maximum one-day precipitation, the number of consecutive wet days, number of consecutive dry days, number of days with rainfall more than 10 or 20 millimeters, and so on. You can calculate whatever you want, but I already done some work for you if you want. Now, why we need so many models? Oh, let's say, yeah. Okay, this is first when I need to ask you whether you have already used this kind of model or not, because contrary to observations, well, okay, but basically contrary to, let's say, even weather forecast or even seasonal forecast, climate model can project very different futures. And especially when you have a large number of models, you can have a very large number of different results. So basically you can have three, let's say, possibilities. The first one, let's say this one is, these are, let's say, projections of, let's say, precipitation, okay? So any lines is the mean, let's say, seasonal mean, whatever you want, doesn't matter. But you can have that most of the model or even all the model agree on the sign of future precipitation, means that in this case, all models agree that the signal is negative, so they will be drying. And for most of the model, this signal is statistically significant. So we are very happy because we have a very consistent signal from the models, okay? We call this signal robust. There are two other possibilities. The first one is this one, where most of the model says that, well, nothing will change basically, or the signal is not significant for most of the models. And we are happy even in this situation because we say, okay, most of the model says that the signal is not significant, so not much will change. Now, there is a possibility, and happens sometimes, where we have some models, they say 50% of 40% or whatever, the model that says, okay, precipitation will increase, and this increase is statistically significant, and 50% of the model that says, oh, well, for me, this projection will decrease precipitation, and this projection is significant. So in this case, we simply don't know what will happen. And this we call this case uncertain, or whatever you want. Okay, now I'll show you some results of my analysis. So this is an example of precipitation at the end of the century compared to the present day precipitation for RCP 8.5. And these are some of these indexes. So this is standard precipitation, the first row. This is the number of rainy days. This is the maximum one-day precipitation, and this is the number of consecutive dry days. This is winter precipitation, or border winter precipitation. And now, these are the column is this CMF5, so the last but one generation of climate model, global climate models. The second column is the CMX6, so the last generation of climate models, global climate models. Then the third column is Cordex, so the regional models, and the fourth column is Cordex Core, so high resolution regional models. And as you can see, there are very large difference in the results. Basically, for instance, if you see over Central Africa, global model projects an increase in precipitation, and high resolution regional model projects a decrease in precipitation. This is a robust signal for the regional model and a robust signal for the climate model. So there is something intrinsically different in these results. We don't know whether it's due only because of high resolution or what else. This is mean precipitation, which, well, you can say as a bad news. However, there are some good news. If you look at other indexes, like the maximum one-day precipitation, all models, all classes of models agree. Even the high-resolution global model, which predicts a reduction in mean precipitation, will produce an increase in maximum day precipitation. Also, the number of rainy days is basically most consistent, even, well, not perfect, but again, you see a reduction in the number of rainy days, even for global models will produce an increase in mean precipitation. What is the message? The message is simply that in the future, there will be less rainy days, but when it rains, it will rain much more intensely. Okay, the intensity of rain will be higher, even if the total precipitation will decrease. And this is a very consistent message across all the ensemble of models. This is another way of looking at the same picture, if you want. These are the signal of indexes. This case, for instance, is the seasonal mean. For the 3 scenarios, this is RCP 4.5, RTP 4.5, RCP 8.5 over some regions here. The details are not really important, but you have to look at the difference between the global models, which are these two, which basically, again, over this is here, the Sahel, basically, the West Sahel, okay, in JGR, so in summer. The global model predict an increase in precipitation, mean precipitation, and the regional models, which are these two, predict a decrease. But if you look at again, the number of rainy days, all models predict a decrease. And also here, for instance, this is South Africa, the Western South Africa. Again, in this case, again, you have inconsistent between global and regional model for seasonal mean, but consistency for other indexes. Okay. Now, conclusion number 1. So basically, well, you can read it, but my message is be careful when you use this output. You need to know what to do. Basically, you cannot simply take the output and use it like that. You need to be a bit critical. You need to understand what you need first, which kind of output you need. If you need just global models, if you need high resolution, how many models you want, how many models you need, how to handle the uncertainty. So these are all things that you need to understand when you use model projections. Now, second part is, okay, assume we want to use these kind of models for impact assessment, basically. Well, the problem of this model, or any models basically, is that they are basically biased. I mean, when you compare with the observation, models are not perfect, so there may be some errors. There is a standard trick, let's call it trick, which is statistical technique, which is called bias adjustment. I don't enter into the details of the technique, but it doesn't matter. Basically, what we do is to adjust the bias in the present compared to observational data set, and then we apply the same function that correct the bias in the future. Okay, so we have a set of bias adjusted projections. So basically, okay, this is just to tell you that these are a range of observation for the subregions, and the black one is the one we use for bias adjustment, which is more or less in the middle of the road, or the spread between different observations. Now, what does the technique does when you compare the results? Okay, now again, no need to know all the details. What you need to know is these are the subregions, so any subregion is more or less the same. These are 1980 to 2010, so a time series of, I think this is maximum temperature, but doesn't really matter. So the blue shades is the range of the original model. Okay, so you have models, and the black line is the observations. So basically, you have models that can overestimate temperature, and models can underestimate temperature up to 3 degrees or so. So the bias can be quite large. When you apply the bias adjustment and you do the same exercise, you have the red shaded. So all of the models basically are very much consistent with observation. This is by construction, okay, because you do the technique to do this, of course, in the reference period. So you have a very much better agreement of models and observation. The problem is what happened in the future, if the climate signal is changed or not, because this is what we want to understand. Now, the simple answer is yes and no. It depends basically on your index, basically. Assuming you have an index that depends on a percentile. Basically, you calculate the number of days with temperature higher than the 90 percentile of temperature, which is a standard index of heat wave. This index will not be affected by any bias adjustment by definition. So if you have this index in the present, for the original model, you calculate the present and the future, you do the same with the bias adjustment results, and you have exactly the same results. The problem is when you have an index that depends on the threshold, like the number of days with temperature higher than 25 degrees or higher than 0 degrees. And these thresholds can be very impactful for instance, agricultural models. And the results are very different. There is a very easy, well, it's not very easy, but it's very understandable way you understand why the bias adjustment correct for this. I don't have time to answer this, to tell you this, but I can tell you later on if you want. But the point is that when you do this, the bias adjusted results is completely different. And this is an example of the number of consecutive days with temperature, for instance, higher than 25 degrees. These are the original models in the future, and this is the bias adjustment model in the future. So you can see there is a much higher number of days with consecutive, sorry, much higher number of not consecutive, anyway, days with temperature higher than a threshold in South Africa, or even in Central Africa and the Gulf of Guinea, if you want. Okay, so there is a huge impact of this technique, but this is not a bad thing. I mean, this is exactly what you expect, because the problem is that the original model were so biased in the present, then this kind of results in the future are not reliable anymore. So the bias adjustment correct for that. On the contrary, for indices in precipitations, things are much better. If you compare the original and the bias adjustment results, they are much more similar for many of the indexes. So you don't have to worry about that. Okay, so this is the second conclusion of my talk. I've done this work of correcting adjusting the Cordex results. I did it only for the RCP 8.5 scenario, not for all of them, because I didn't have time. There are more or less 20 or so runs for this. They are already available. This is the repository where you can download them if you want, but if you do, please contact me, because I think you need some guidance how to use them. And these are basically what I told you about the impact of this bias adjustment for indexes or threshold-based indexes and percentile-based indexes. And I think that's it. I don't have much more to tell you. No, I'm open to questions if you have.
Thank you very much. I will allow you to unmute yourself. So
Yep.
so everyone can ask questions first, or you can raise your hand, so it's going to be easier to manage. Before that, maybe for icebreaker, I can ask you 2 points, 2 questions. The first question is about all the climate model you have in the database. It's pretty large. We have a lot of regional model, climate model, global model, and regional model. And my question is, do you think that it's necessary to use all of them, or to select some of them? Because, for example, it's the graphic you showed here previously, when you have a global trend of all the model going to the same direction, or when you have different trends, some model are going up and the other down for the specific trend in temperature or precipitation or whatever. It can be also explained by one model which is not specifically good in such a region. And my question is, do you think more we use models, the more the data, the better? Or do you think it's important, depending the region, to select certain model?
Yeah. First, one thing to tell you is that there is not a real correlation between the bias in the present and the signal in the future. So it's very difficult to select model. I have a strong background noise, so if someone can...
Yeah, this is the problem when we open to...
I wait for you to mute everything.
Okay, it's done.
Okay, thank you. So there is not a reliable correlation between the bias and the future climate, meaning that if a model, let's say, is negatively biased, let's say, is too dry in the future, in the present, doesn't necessarily mean that it projects a drier future. Okay, so selecting models on the performance on the present is tricky. It's tricky, especially if you do on let's say standard metrics like mean precipitation and mean temperature. What you should do is to go through a process-based evaluation, but this is very tricky and very technical. So apart from this, yes, you could select models based on, for instance, the projected signal. Okay, probably you don't need 30 models to project your future spread, but what you need to ensure is that spread is conserved as much as possible. Okay, you don't want all model to go in one direction. Is the complete range of original models have a very little spread. You want to preserve that. So you can select this. There are many techniques to do that. Yes, you can do that. The problem of uncertainty, unfortunately, is not so simple, especially over Africa, and especially because say you can go here. Sorry. Usually the problem is that usually the models are more uncertain when you need them, especially over Central Africa and over West of Africa, especially during the monsoon season. Okay, so there, yeah, you need as many models as you can. This would be my suggestion, or at least select models that give a different answer, because you need to be prepared for this kind of uncertainty.
Okay, thank you. And the second point, the second clarification was about the data you propose and could be inserted into the ClimSA station are already bias corrected.
Yeah. Okay. There is a set of bias adjusted projection, but only for RCP 8.5. I won't do any other scenario anyway. So this is what you get from the Cordex models, which are 0.44. And these are these simulations here. These ones, okay? You will have all these, more or less 24, are available, are already bias adjusted. You have daily data from 1981 to 2100 for mean temperature, maximum temperature, minimum temperature, daily precipitation. These data are available. For the rest, no. You can, well, whatever. All the other daily data, even for the CIMEC 5, are freely available anywhere. I mean, if you want to use them, I don't even know if it's, well, this is up to you if you want to store the data on your server and then for the visualization point of view. But if you really want the data, I think it's easy. I don't know if it's easier or faster to download it from ESGF. I don't know. This can be decided. Where for the indexes, if you need the indexes, then yeah, I can provide some of these on the server, because I have them for, I think, I don't remember if them for all of that, even for this, I don't remember to check. The only thing is that I have them only for precipitation, because my study for the comparison of global and regional model was done only for precipitation, not for temperature. But again, it's something on this.
Yeah, that is a question also we can ask directly to all the partners that are now in the chat, if they are interested. I'm sure they are interested in using such in the index. So if you are interested, just raise your hand and we just talk about that. I saw one question from South Africa. Shifizo, the floor is yours. You can unmute yourself and ask your question.
Good day, everybody. Just hoping everyone it's after 12 p.m. Thank you, Alessandro, with your presentation. I'm very delighted and happy with the inclusion of the WMO expert team of climate change indices, because I work with them intensively, running them on RClim index, RClim index. So my question was, I saw that you pointed out that the models are showing that there's going to be a decrease in rainfall events which is something that has been talked about intensively. So I wanted to know if does having rainfall, a decrease in rainfall events translates to having droughts, then because it is said through your presentation that if the rainfall events occurs, we're gonna see more or intense rainfall. So is it still safe now to use the seasonal total rainfall to assess if the season was a drought or a wet season? Because I'm saying this, we can have like 60 days, maybe in a rainy season, 60 days, just as an example, 60 days where we don't receive rain, and then we have maybe the last 30 days of rainfall, and then this rainfall is more intense. And then when you look back after that season, you look back and you see that rainfall that was received is more than the other season, and then one might conclude that there was a wet season when it was actually a drought season. So is it still safe to use total accumulation or annual total accumulation to assess if the season was a drought or a wet season? Thank you.
Yeah, well, this is a very interesting question. The problem is that I don't have an answer. I mean, let's say like that. These results I show you are seasonal results, and these are for the GEF. I have the results only for also for other season. In my paper, they don't show them. And this is a tendency for the seasons, okay? The problem is that the results depend strictly on the region you're interested, and also depends on what you want to do with your data, or what is your aim. Because even if you see at the maps here, you see that yes, there is an increase in 1 day precipitation maximum, but not everywhere. Okay, so it depends. If you look at, for instance, the Northern Africa or the seasonal, even on the Atlas regions here, you see that there is a decrease, and this is consistent over for all the models. So if you are in Madagascar, yes, there is strong increase. So the answer depends on the region, but the tendency of general reduction in the number of days and an increase in the extreme precipitation is more or less robust. The problem with drought is that, yes, you see usually an increase in the number of consecutive days, but drought is a very, let's say, problematic definition of, well, you can have different definition of drought depending on what you want. And so, the precipitation is just an index of meteorological drought. If you're working with hydrological drought or agricultural drought, you should probably use other indexes like SPI, for instance, okay? I didn't calculate SPI, but if you do, you will probably have different results. I don't know. So my question is, yes, I would be happy to if you want to do that, to look into this data on your particular region, yes, I will be happy to help with you, but I don't have the answer for you by now.
Okay, thank you. Yeah, the computation of SPA, I think, is inserted into the ClimSA Station, so it can be also computed inside. I have to discuss with. We're going to discuss later on that, but that could be a possibility also of using the ClimSA Station for doing that. There was just a quick question for Newsen about the data available on ClimSA. It's exactly the topic just after the Q&A session, so we're going to discuss about that. Just after when we have no more questions. I see a hand of Mr. Lona. If you want to ask a question, the floor is yours.
Okay. Good afternoon, everybody. Thank you, Anderson, for your presentation. Yes, I didn't well understand why the Cordex score model didn't have data for the RCP 4.5. I didn't well understand.
It was a choice. It was a choice by the modelers group, since these runs are very expensive, and since let's say from the we have a lot of information from RCP 8.5, for instance, but not so much for RCP 2.6. So the first target were 2.6, and then they say, well, if you have to select two scenarios because we don't have resources to do 3, it doesn't make much sense to do 4.5 if you already have a 2.6, so decided to do 8.5 to have a much different signal between the two of them. This is my guess, but it was just made because of computational resources. You didn't have the resources to do all of 3, and then it's to do only 2.
Okay, thank you. Is there any other questions to ask for?
Yes.
Alessandro?
Yeah. Thank you for the presentation. I would like to ask on the regional models, yeah? Are they like part of CMA 6 or 5? This one, the regional one.
Yeah. Sorry, I forgot to mention. No, Cordex Model downscaled only CMAC 5 results because when they started, let's say 10 years ago already, that was what I mean. Cordex said a bit of history. Cordex started in 2009, I think, with the idea of producing results for the IPCC AR5. But they didn't because it was too much of a work. There was no time to have results for that time. So the results of Cordex, CMF5 downscaled Cordex results were used in AR6, basically. Now, there is a ongoing work that started a couple of years ago of downscaling CMX6 results. This is true, but the job has just started. And as far as I know, unfortunately, there is no group interested in downscaling Africa. I don't know why, but so far there is no group downscaling CMX6 result for Africa. To me, it's a shame, but this is what it is.
Okay, last question, or we can go ahead. If there is no more questions, okay. So in any case, we can share. I mean, if you accept that, Alessandro, we can provide also your email if someone wants to join.
Yes, sure.
So I will, or you can write in the chat the email, your email. So
you can even. I can distribute the presentation if you want.
Yeah, but if you can send to me, and I will put into the into the materials for the ClimSA, and I mean the session is recorded and will be on YouTube. If you okay, your email is here. Okay, perfect. Thank you very much, Alessandro. If you can stay, we can discuss now about a few minutes. We can discuss about the implementation of such kind of data set into the ClimSA station. So basically, the idea is to take some data from your database and to put in the ClimSA station. So basically, if some partners want to use it, they can. So maybe you should stop sharing your screen, and because I think Vijay will show an example of the use of climate data sets. Thank you, Alessandro, again. Vijay, it's
Hello. Yeah. You see my screen?
Yeah, perfect.
Okay. So again, to quickly show what you see is in the ClimSA station in our production server. Whatever Alexandro Dosio showed, I tried to download some of the data from the website he mentioned. So some of the examples are here, so I will quickly go through those examples. But the idea of having the climate projection data set in the ClimSA station is not as the same way how we do the acquisition of other products. Because, for example, the seasonal forecast, we configure the things from the climate data store, and then in each month we download the data set consecutively. So this is what we have been doing, but for the climate projection, we don't want to do this approach because we don't know what you are interested in and what is relevant for your region. So what we decided to do is to have like a notebook where you can drag and drop your interested data sets and then start working with it. So here, what I'm showing you is just a quick example from the website, what they mentioned. So I downloaded some of the data sets and then I dragged and drop here, and then I created a quick interface just to show you what you can do in the ClimSA station to visualize them. But if you are familiar working with the XRA libraries, you can also do even more things using the climate projection dataset. So this notebook, I can share it with you. The first example is the CMIP6 dataset, and then what you see is the consecutive dry days. So once you select the list of files, what you drag and drop in your folder. So for example, there is a list of data sets I downloaded from the website and then dragged and dropped in my folder. And with this notebook, it lists all the netcdf file available in this particular folder. And then once you select the file, automatically it displays the list of forecast time. And then by selecting a particular time, you can visualize the data set. So for example, here I selected the consecutive dry days, but also the rainfall over 10 millimeters. So this is the heavy precipitation day, which is the sum of precipitation exceeding 10 millimeters. So these are the list of example I made, and then you can select the forecast time and then just visualize them. But of course, this is just a starting point for you. If you come up saying, okay, this is the data set you identified for your region, and then you say, okay, this is what I want to display in my ClimSA station, and then we can create similar notebooks for you, what exactly fit for your use, and then I can start distributing them. So this is the planned activity we decided to do for the climate projection data set in the ClimSA station. So this is the CMIP6, but also I have the Cordex, a separate notebook for Cordex, and then here what you see is the temperature near surface air temperature displayed in Kelvin. So this is the projection starting from 2071 until 2100. And then of course you can also visualize the data set. But again, I understood from Christoph that it is not necessary to view each day. So what I quickly made is to do some calculation, and I did the average of 10 years, for a composition, like 71 to 79 years, and then 80 to 89 and 90 to 99. So similarly, if you say, okay, this is what you want to display, so we can create a notebook so that you can work with these kind of data set. So it is necessary, I need some input from you, or what you're interested to do, which kind of data set you are interested in. So you can go through for anything on the climate projection, you can write to Christoph and Alessandro Dossio. Then once you identify the product, and then write me, okay, this is what you want to visualize, so these kind of graphs are interested for you, so I can prepare you a notebook and then provide to you, so that it is going to be this kind of one-to-one development. So we co-developed in the ClimSA station Jupyter notebook in such a way. So this is again just an example. So if you have any doubts, I can clarify. But I guess you understood the point how we are going to have the climate projection data set. It's not going to be acquisition every month or every year. There is not going to be a data set you can configure from the portfolio.
Yeah,
Is it okay?
Yeah, it's a preliminary work. I mean, this is only done for our ClimSA station for the moment, and of course, we just want to have. We just started to play with, but the idea of the today's meeting is to start having such kind of collaboration with you about identification of the needs. If you need the outputs from the models, from which models, for the global climate model, for the regional climate model, or if you prefer to use directly the indices that Alessandro presented in the previous presentation. And yeah, that's it. It's the idea of having the ClimSA station. For the moment, it's a proposition of having such kind of functionality together with the others that you're using already, the seasonal forecast or the monitoring. So the floor is open. I mean, I don't know if you want to add something, Vijay, or we can open the floor to everyone. I mean, if they want to speak about, if you want, they have a specific requirements, feel free to raise your hand or directly to open your mic and about because we really need to have your feedbacks. We will need to have your yeah, what is really your needs, what you want to do with the climate projection, because according to the survey, you would like to add this kind of data set into the ClimSA station. So floor is yours. Who wants to? No one? No needs? Don't be shy. Simon? Is it a mistake or? It's a specific needs. I don't understand exactly, but Simon, I don't know if you want to speak.
I'll simply be listening in.
Okay, it's
no.
So no specific needs.
No, I will not be saying anything. I'm just listening in at the moment.
Okay. So no one has a specific needs, or do you want any? Yeah, I see from Eswatini. There is a yeah. The floor is yours.
Yes. Good afternoon,
Good
everyone.
afternoon.
Yes. Thank you for the presentations. You know, I was actually asking as to how do we integrate the data from ClimSoft into the ClimSA station. I didn't see that. I just saw that.
Okay, it's another. Okay, it's back to the Jurjen. Maybe you can answer to that. So if there is no specific needs for the moment about the climate station, we can go to that question, Jurjen, about the ClimSoft.
Can you repeat the question?
Eswatini, could you repeat the question? It was about the ClimSoft.
No, yeah, during the time when they were presenting about getting data from ClimSoft into the ClimSA station, I didn't see how we can take the data from the ClimSoft into the ClimSA station.
Yes, and that is actually not yet implemented. So we are busy doing this, and okay, for only for ClimSoft, I can because I have an installation of a ClimSoft, I can guide you, write a document where you can follow, let's say, instructions on how to export the needed data from ClimSoft. And then when the import functionality is ready, and that will be communicated, I think it will be probably in September somewhere. Then we will have also the import functionality within the Jupyter Notebook. And yeah, okay, once you can then update your system, you can start uploading your data into the climate station.
Okay, thank you. Maybe another question. I saw that you now have ClimSoft version 1.14.
Yeah.
Do we still need to use the same the manual, the one we used when we were upgrading from version 1.12 to version 1.13, or we have another manual for upgrading to version 1.14?
You mean for ClimSoft?
I don't mean ClimSoft, I mean ClimSA.
Ah, okay, sorry. No, actually, it is just an update. You will use the CS installer, and just follow the instructions in the manual to update, which are actually only 2 instructions that you have to follow. And since there is an update in the .env file, you will be asked then also to change some settings in the .env file, and that's it. So it is the same manual, and it is a small update. It will actually integrate also impact within the installation.
Okay, thank you. Maybe another one again. During the time when we were in South Africa, during the training, you know, I think SADC spoke about because we have some internet problems here. Then SADC spoke about is it satellite internet from Elon Musk or something like that. I just want to know if something is happening in that regard, you know.
At the commission level, we had a discussion with another unit about providing the possibility of providing internet through another service that is not the one proposed by Elon Musk. It's ongoing internal discussions at the moment at the GRC to see if it's possible to support some RCCs that have issues with the internet in some regions. So it's ongoing discussions. For the moment, we don't propose to use an internal system, and I mean, it's up to you if you want to use the one proposed by Starlink or another. But for that, we cannot support you. I mean, in the sense that we are completely out of this project. So, but there is an equivalent of a system at the European level, but it is very ongoing discussion. So as soon as we have some points related to that, for some updates, for sure we will communicate to you.
Thank you so much. I think that's all for me.
Thank you. Question from Tanzania.
Yeah, hello everyone. I hope everyone is fine. From Tanzania, we succeeded to install the ClimSA version of 4 and temperature monitoring. We are only capable of getting the product from rainfall monitoring on. So we're asking if there is any way communicating with you to solve that challenge, because product is really important to our sites. Thank you.
Maybe what you do is you can put your email into the chat, and VJ, I think, will contact you to, or you or VJ, both contact you. Then you after the to
So yeah, also write me with the difficulty you face, what is happening with some shots, so that we can do the discussion one to one. Or we can meeting.
That's done.
Thank you.
South Africa.
Also, all I'm not